Okay, what we're going to do here is to recap the very basic definitions of sine, cosine, and tangent, and estimate some values using the unit circle that's in front of us. I've added a unit square around here. That'll help a lot with the slopes. I also want to put in a little line thingy um, to find the slope as we can. Now, just a few reminders. All the way around the circle is exactly 2 pi. Well, 2 pi is about 6.3, so all the way around the circle is about 6.3. Halfway is exactly pi. I'll either use 3.1 or 3.2 when we're doing these unit circle estimates. When I get to the top, that's half a pi, which is about 1.57, but usually 1.6 is enough to deal with that. Down at the bottom, I get 1.57 plus 3.14, that's 4.71. I'll usually call that 4.7 and just sort of live with it. Now what happens when we do unit circle stuff, we're told always start at the 0.10, and then when we start going counterclockwise, the distance is positive. When we go counterclockwise, the distance is negative. And I would like to just start looking at a few little examples just to see what's going on. Now the first example I want to look at, I think, is the sine, cosine, and tangent of 1. Now 1 means I go distance 1. Now if I start here and I go all the way to the top, I've gone about 1.57, which is too far. One thing I usually try to do is divide this into quarters. So if this is about 1.6, halfway would be about 0.8. 3/4 way would be about 1.2. And I'm thinking I only want, what, about a third of that. Let's see here. If I go to about there, what do you think? You think that'll work? Maybe a little bit further. I want it to be about 2/3 the way from here to here. Now the idea is I want to find the cosine of 1, the sine of 1, and the tangent of 1. And we've gone about distance 1, so I'm just going to look. If I click and hold here, I'm going to see the coordinates. The x-coordinate is about 0.5. Remember, the x-coordinate's cosine, so we're saying that the cosine of 1 is about 0.5, maybe a little bit bigger. Remembering that y is the tangent. No, y is the sine. And so the y-coordinate here is going to be about 0.8, so we're saying that the sine of 1 is going to be about 0.8. Now the tangent is the slope. I can see, for example, that this is going to be about 1.6. But what I'm going to do is actually count squares and just go rise and run. So the run is going to be 1, 2, 3, 4, 5, like 5.5. The rise is going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be about 8 over. It's going to be about 8 over 5.5, which I'm thinking is about 1.6. But that's the number we're going to put in my table. Now let me just take a picture of the screen, and we'll do the next example. The next example I wanted to look at was 1.5. I'm going to go over to 1.5. Now what does that say? I want to go distance 1.5. Well, all the way to the top is just a little teeny bit bigger than 1.5, about 1.57. So I'm going to go almost to the top. Now, going all the way to the top is about 1.57. I just want a little bit less than that. I'm thinking maybe about there. Now, what do we want again? We want the sine, the cosine, and the tangent. So I click and hold, and I see that the cosine of 1.5 is the x-coordinate. That should be about 0.06. The y-coordinate is, you can see that it's almost 1. It's going to be 0.9982. And the tangent is going to be the y over the x. It is going to be the slope. So what I want to do here is see how much rise and how much run I have. I can see that the run is only about 2/3 of a square, and that the run is all 10 squares. So I'm going to get 30 over 2/3. It's about 15. So I think I'm going to get about 15. I'll take a picture of the screen so we can punch that in. I'll look at the next one. Next one says go distance 2.4 and try again. Now 2.4, let's see. The top is about 1.6. The side is 3.2. Now 2.4, it would be exactly in the middle. if those were exactly right. So I'm just going to say that's about right. It's not going to be quite right, but it's pretty close. If that's exactly 1.6, and that's 3.2. So this is the number I'm going to pick just for my estimate. I'm going to go click and hold so I can see the estimates. The x-coordinate is the cosine, and I can see that's about minus 0.7. The y-coordinate is the sine, and that's also about 0.7. The slope would be the rise over the run, but I can see that the rise and the run are identical size here. I'm going down about negative 0.7 and then over 0.7, so I'm thinking the slope is going to be about minus 1. I'll take a picture of the screen again, and now we'll go look at the last one. The last one says go distance 4, and then find the x-coordinate, the y-coordinate, and the tangent. So what I'm going to do is I'm going to go distance 4 as far as I can. Now I know that this, if I go halfway, is exactly pi, which is 3.1 or 3.2. If I go all the way down to the bottom, that's about 4.7. Now, if that's 3.2 and that's 4.7, then halfway in the middle, just like that, is going to be something like 3.95. But I wanted to go distance 4, so I want to go a little bit further than that. I'm just going to go a little bit further, and I'll live with that. And now I want the x-coordinate, I want the y-coordinate, and I want the slope. So I click and hold, and I see that the x-coordinate is about minus 0.6, the y-coordinate is about minus 0.7, how about minus 0.65, and minus 0.75. And the slope is going to be the rise over the run, which is going to be a little bit bigger than 1. It's going to be negative 0.76 over negative 0.646, whatever that happens to be, and we'll try to work that out before we put it in the table. Meanwhile, I'll take a picture that we can put in our table, and we're going to be done for the moment.